So big ideas from quadratics, or we could find, these are called X-intercepts, and everybody should be able to factor, because we did that in chapter 1. The other thing that's new for us this year, something we talked about in Algebra 2, but something new for us this year, is that if you take your quadratic and you figure out A, B, and C, so in this example, A equals 1, B equals 3, and C equals -4, right? Because we used the quadratic formula already. So we can pick out A, B, and C. We can also find the X value of the vertex. We can find this point. This is idea 2. And it comes from X equals -B over 2A. It's the beginning of the quadratic formula. So in this problem, if I go negative B, right, over 2 times 1, 2, negative B over 2, I did something wrong, positive 4. Oh, I'm a dummy. Look back here. This should have been positive 4 and -1. That's why y'all have to be not on mute so I don't do something stupid. So this has to be positive 4 to make positive 3. That means that this is positive and this is negative. So these points are different. So in order to factor things, we're always looking at factors of the constants. They have to multiply. So like x plus 4, right, that's me thinking about how to factor it. Okay, so anyway, now that I've fixed this, I really have this picture where I have -4 and +1, and now this makes sense. If I go to x equals -3/2, that's the same thing as -1.5, right? So that's here. That means that on this line somewhere is the vertex. And if I plug it back in, I can find out what that is. I didn't choose a very pretty one for this problem, but it's going to be x squared plus 3x minus 4. If I plug this in, that'll be -3/2 squared plus 3 times 3/2. Sorry to get fractions. I didn't mean to, but here we are. That's going to be 9 over 4. 3 times 3 is 9 over 4. Plus 9 over 2 minus 4. And I'm going to pause right there, because multiplying fractions is not people's favorites. So how am I doing? Does that make sense? I found, like, this is something that was given and I talked about in the videos. Now that I found it, and I'm going to use 3/2 because it's easier, I plug it back in, and then I do the math, and then even if I pulled out a calculator to do this, I could, or I can find a common denominator. If I put them all over 4, this would be 18/4 and 16/4, and that ends up being -7/4. Wait. That's going to be negative. I really am bad at negatives today. There we go. Better. Okay, so 9 minus 18 is -9, and -16 makes -25/4. So that's like a little bit more than 6. 1, 2, 3, 4, 5, 6. Here's my vertex, and here's my parabola. So there were two ideas. One of them was to factor, and one of them was -b over 2a. Because if you know this value, you know the vertex. You know where the function is going along, and it's going down, 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 and then it changes direction and starts going up. What was your question, Marco? what did I do with this? This is a point. It's called -3/2, -25/4. This is the lowest y value. The function goes down and then it turns around and goes up. Did somebody join us or did I miss that? No, just my 4. Did I lose Matt? Matt, where'd you go? Hopefully he'll come back. Okay, so Marco, do you have like a question from the homework that you'd like to see me work from this section? Then y'all can pause and ask me questions. $20. Okay, page 235, and which number? 20? Okay, so in number 20, we're given a function. It doesn't matter what they call it. This is g, x squared minus x minus 6. So we're going to do both of those things. Okay, number one, we're going to factor it. So we're going to go 0 equals x squared minus x minus 6. What are factors of 6 that subtract and make 1? We either have 1 and 6 or 2 and 3. So 2 and 3? Yeah, 2 and 3. And I know they subtract because there's this minus right here. So I'm going to do this right this time with my signs. Which one gets the negative? Okay, now I lost Sam. 3 gets the negative. Okay, so this one gets a positive, and so these are the two x-intercepts, x equals 2, -2, and +3. So I can already graph part of this. I know at -2 I have a dot, and at +3 I have a dot. And I did it right this time. Okay. And I know my parabola goes up because this is positive. So I know it does something like this right here. But I need to know where it turns around. So number 2 is to find -b over 2a. That's going to be a fraction again. That's great. So we've got the vertex is going to be at -b, which is -1, over 2 times a, which is 1/2. Does that look like it'll make sense? That means that right here somewhere is a vertex, and that does look like to be the middle, so that makes sense, right? Okay. Now I just have to plug it in. It's not my favorite because it's a fraction, but we could even type it into here and see what happens, right? So we could, is it showing up? It's too shiny. There we go. We can say plug in 1/2 into my original equation. That's going to be 1 divided by 2 squared minus 1 divided by 2 minus 6, and it'll just tell me -6.25. That was handy. So now I have an x value and a y value. And so at 1, 2, 3, 4, 5, 6. So this is the x value. -b over 2a equals x. So if I find x, I can put it right here in the original equation. So I did 1/2 squared minus 1/2 minus 6. And because this was practice work, I just pulled out a calculator and it told me -6.25. Sam's back. So now we have a parabola. So this is 146. All right. Hey Sam, you're back. So we found the vertex with negative b over 2a, and we said that it looks like this now. So we factored it, and these were the x-intercepts. And then so this is the vertex. This is this point right here. So with those 3 points, we have a graph. And that's what they asked us to do, was find the vertices and x-intercepts. And so we found 2 x-intercepts in the vertex. So you have to memorize negative b over 2a, but it's the beginning. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You already know the quadratic formula. The vertex is this part. It's straight from the quadratic formula. So y'all already know this. You just didn't really think about it being part of the what this quadratic formula does is it finds these values and it adds an amount and it subtracts an amount. This is the plus or minus the same amount. But this part tells you the x value of the vertex. It doesn't tell you where it is up or down, but it tells you what to plug into the original equation. So that was 20. And then, so y'all did 16 through 21 and 24. And that was probably easier if you write it out. And then the 24. Did anybody want to see 24? Was that a yes or no? I couldn't tell. Yes, okay, 24. Let's look at 24. There are a couple ways to do it. You can tell me which way you like. So here we go, 24. 24 is the same kind of thing. They want us to take this function and they want us to find the x-intercepts and graph it. Now this function is easier for me to look at if I write it with the 1/4, this 4 in the bottom, if I put it to the front and then write x minus 1 squared. And the reason for that is that now I know that this is going right 1, and I know that this is a shrink factor because I'm multiplying everything by a 4th, and it makes it smaller. So this makes it easy because now I can see the vertex. Normally the vertex is at 0, 0, but this one has been shifted right 1, so it's at 1, 0. But if that doesn't make sense to you, you could definitely multiply this all out, multiply by a 4th, and use negative b over 2a. But this is the translated equation. And also, so this is actually the vertex. This is the step number 2. But if you want to do step number 1 where you factor it, you just write it the same equation that was given, 0 equals 1/4 x minus 1 squared. Is this already factored? Sorry, my lights will come back on in a sec. There we go. It is already factored. It has 2 things equal to 0. 0 equals 1/4 or 0 equals x minus 1 squared. Now 0 equals 1/4 is not true, so we mark it out. But this one we can actually solve. So we can take the square root of both sides and get square root of 0 is 0, x minus 1, so x equals positive 1. Which means that this is also the x-intercept. So not only is this the vertex, it's also the x-intercept, which means that the graph looks like this. At 1, it's an x-intercept, and it's the vertex. Oops, except it's probably pretty fat because of that 1/4. So it probably looks fat. It grows slowly. It would not be this one. It would be a big fat parabola. And we could plug in other points to get it, but this is a sketch. So the things you needed to remember were factoring from before, and then negative b over 2a is our new thing from this section. So anytime you have any parabola, it doesn't matter what it is, if you do negative b over 2a, you can find out where the vertex is. That was the gist of this section. What? So 17, you'd need to multiply out if you wanted to use negative b over 2a. 17, so multiplying it out for 17 would look like this. Just for everybody's sake, because I'm recording it, it would be negative x plus 2 squared, means write it again, and then minus 1. So then we'd have negative, and then this turns out to be x squared plus 2x twice 4x plus 4 minus 1. And then we distribute the negative to all three of these and get negative, oops, losing my paper. Here we go. Negative x squared minus 4x minus 4, and then there's still minus 1 on the end. Negative x squared minus 4x minus 5. So negative b would look like negative 4, because this is b, over 2 times a, which would be 2 over negative 2 or negative 1. So this would be the x value of the vertex. Wait, I'm sorry. Okay, bad math again. Okay, so what does it say? Negative. I was already doing the 2 in my head. It should be negative 2. My bad. This is 4 and this is 4. 4 over 2 is 2. Okay. But it was given to you in vertex form, so you could pick that out from there. We did a lot more than that in Algebra 2 here. Okay, Andy and Sam, y'all are really quiet. What questions do you have? Matt, are you in the same picture? I just can't see you. Oh, that works out good. Okay. Why didn't y'all do that before? Yeah, you might as well be together. I don't care. I mean, you just can't be at school. You can be together, as far as I'm concerned. Okay, so Marco's got a lot of questions. What questions do y'all have? Or does this help? Okay. So I need for y'all to remember this. And then we'll definitely practice some more problems with it. Yeah. You're right. 17, it goes down because it has a minus in the front. So this minus means that at negative 2, and if we plug that in, it's going to be negative 1, negative 2, negative 1, and then it's going to go down because of this negative right here. It doesn't have any x-intercepts. Yeah. If you solve this with a quadratic formula, you'd get imaginary numbers, which means that it doesn't cross. Yep. Here's my paper because it fell off. There we go. So if you put this in the quadratic formula, it would, see, here you go. The original problem said 0 equals negative x plus 2 squared minus 1. Which, if we take one of the other of these and put it on the other side, let's say that we put this part on the other side, it would change signs to be positive x plus 2 squared equals negative 1. So what happens when you need to get the x out? How do you undo the square? Remember, what's the opposite of squaring something? Square root. So we're going to go square root. Square root. Can we take the square root of negative 1 and see it on a graph? No. Square root of negative 1 would be imaginary. So this would be an I. This would be imaginary. which is why it doesn't actually cross the x-axis. It goes down from the vertex on either side and doesn't go up and cross it. So we can't find anything for that right there. Okay, what other questions? What ones from 54, 55, or 56 from Tuesday's homework? Anybody want to pick one of those to look at? Or did I give enough explanation in other videos? Because there was tons of videos to watch. Hopefully y'all watched them. It's a lot of stuff. 55. Thank you. All right, so 55. So 55 has directions that start on the page before it. And the 55 directions say, here's an equation. And here's what it means. This is gravity, right? So if you throw a ball up, it's going to come down because of gravity. This is the number that reflects gravity. Then velocity means that in 55, they say a ball is thrown upward. So this is the person throwing it and how hard they threw it. This is 48 feet per second. And then height is where the person's standing. So they're standing on a 144 foot tall building. So they told us use this equation, and in this problem they told us these two pieces. So is that good? Like that part makes sense? Okay. So now we have h of t equals negative 16t squared plus 48t plus 144. Okay. It says a ball is thrown upward from a velocity of blah, blah, blah. What is the maximum height of the ball? So you can imagine there's a building and there's a person here and they're throwing a ball and we're looking for this, right? Does that make sense? I mean, it's a building. It's not really, but you know what I mean. So we need to know the height. Does this look like a parabola? Yes? And this looks like a parabola, right? With a square? So the same rules apply. We can find out the x value here by doing negative b over 2a. So Matt, what's b? So remember, if we write them in order, it goes a, b, c, right? A, B, C. So it's really going to be negative b. Yeah, so negative 48, because we've made it opposite, negative 48 over 2, and a is this one, negative 16. So what does that mean? Negative 48 divided by negative 32. So is that like 2/3 or something? $16 goes into 48 3 times, yeah. Okay, so all grades will shift to virtual learning through Friday, January 21st. Sorry, I just got that mail. Did y'all see it? We'll return to campus on Monday. Okay, so there's that tidbit. So the positive and negative cancel out. We have 48 over 32. 16 goes 3 times and 2 times. This is at a second and a half. He throws it, and 1/1000 whatever, it gets to the top and then it turns around and goes back. So 1.5, is that time or height? Time. In order to find out height, we have to put the time in. How about that? Does that make sense? So now we can find the height, because this is called the height function. That's why they named it h. If we put in 1.5 into our calculator, and I'm totally fine with y'all using your calculator in these cases. So I would type in this equation just like this. Oops, just like this one. So I'd say negative 16 parentheses 1.5 squared. So I'm plugging it in right here. Plus 48 times 1.5 parentheses plus 144, and it should be bigger than 144, and it's 180. So that is 180 feet. So the ball is thrown up, and then it reaches 180 feet, and then it starts to go back down. So it seems like a really hard problem, but if you understand that things that are thrown upward have a parabolic shape, they look like a parabola, then we can use negative b over 2a for when it happens. This is the when, and this is the how high. And those two things students have trouble with, but hopefully this helps help it make sense. It's just as easy as finding negative b over 2a. And it probably didn't have this shape. It probably went, it wouldn't have gone straight. Well, it depends on where you threw it. But anyway, this person down here is very sad because, yeah, it's going to hit him in the head pretty hard. So there were other questions that used this same formula. The same formula, but you put a different number here and a different number here, which meant that the time was different, but the process is exactly the same. So you can do that with any equation where you fill it in like this, and you just use negative b over 2a. It's actually pretty simple. It looks really hard, though. Do you agree now that it's simple? At least I hope so. Yeah, okay. Okay, so we've got about 10 minutes. If you need to try other problems from that section, I suggest that you do, and do use your calculator. It's fine. The next section y'all looked at was 3.3, and we looked at things like if it was x cubed or x to the fifth, it had this sort of shape to it, where one side goes up and one side goes down. Even it could have been x to the first degree, but anything odd had this shape. Do you remember doing that? We did that last year. Also, if it's even, so x squared or x to the fourth or x to the 16th, it doesn't matter. Anything that's even, like this parabola, had an even power, it's going to end the same. It's either going to go up or down, but both of the arrows are in the same direction. So that's a lot about what this section was picking out what kind of function it was. We also looked at some parent functions that had fractions. So 1 over x looks like this. And I printed a sheet, right? Didn't y'all get a sheet in class that had all these different parent functions on there? Yes? Yeah. Okay, so I'm going to let y'all use that as a reference, okay? Because there's a lot of different functions on there, and you understanding it is the most important thing. You'll be able to recognize it better as time goes on, but especially with us being virtual this week, using that reference sheet is handy. So if you don't have one, if you can go back to that lesson 3.3 and reprint it, that would be really helpful to have that sheet. It talked about other functions like what the square root function looks like. So it looks like this versus the cube root function, which looks similar but different. It has this piece, but then it also has this piece. Oopsies, you can't see it. Sorry, my bad. Okay, so it had all of those functions, and I would like for y'all to practice that. And then the second day, y'all had to do piecewise functions. So now I'm opening the floor. So Marco, I don't know where you went, but what questions do you have from 3.3? Okay, you're good? You answered the questions? Okay. So piecewise functions for you guys are hard? Yeah, so there's no homework tonight. There's just me trying to answer questions before we move forward any. Okay? Okay. Andy, Sam, and Matt, what question? Marco, you can exit if you're good. Like you can say or you can exit, whichever. What questions do y'all have from this section? Okay. 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 Well, I tried to make it just as straightforward as possible, but it does start to add up. So if you don't start memorizing things like which function is which, then it gets really, really confusing, I think. So, okay. Okay. Well, if y'all are good for now, I don't know exactly what will happen tomorrow. Typically, tomorrow would be a double block. And I don't know, since they sent that email out, what they're thinking. I might have to ask. I don't know I don't know. But there's grace, okay? So if I give you something for tomorrow and your other 4 classes they decide to do double blocks, you can just let me know, okay? Say Senior Kiros is doing a double block Zoom session, so can I double block your stuff on Thursday? And that's fine. Is that fair? Because I don't really know what anybody's doing. Because I got that email during the Zoom. So, okay, well, then we're good. Thanks for coming. And if you find you have questions, just send me a note, okay? All right. See you later. Okay, bye.